Hello and welcome everyone to AABN's 266th weekly webinar. I am deeply honored to present myself before you today as a humble representative of AABN. It's truly inspiring to see so many of you gathered online on a Sunday morning, continuing a tradition of learning, sharing, and growing together. Through these weekly sessions, AABN has not only kept our entrepreneur community engaged, but also created opportunities to meet inspiring thought leaders who can shape ideas and spark innovation. Our webinars are carefully designed to help business owners, managers overcome common challenges, refresh their perspectives, and stay ahead of emerging trends. As you all know, AABN is an umbrella friend of entrepreneurs from across the globe. We take pride in being a platform that connects diverse minds, fosters collaboration, and brings fresh insights to our community. Today's session is yet another step in that journey. The focus of today's webinar, Geospatial Insights into Seismic Hazards and Impacts, is both timely and vital. Seismic hazards pose serious risks to communities, industries, and economies worldwide. Understanding these hazards through geospatial technology not only enhances disaster preparedness, but also strengthens resilience and sustainable development. For entrepreneurs and professionals alike, such knowledge is invaluable in shaping strategies that safeguard both people and investments. It is my privilege to extend a very warm welcome to our distinguished guest speaker, Professor Guru Balamurugan, Professor and Head of the Department of Geology, School of Earth Sciences, Central University of Tamil Nadu. Dr. Balamurugan is the founder, Head of the Department of Geology at CUTN, where he has initiated and developed advanced laboratory facilities worth rupees 42 million, including ICP-MS, XRF, UAV, drone, geophysical resistivity instruments, and other cutting-edge equipment. He holds a PhD from the prestigious Indian Institute of Technology, Bombay, and has completed a certificate course in surface water resources from ITC, the Netherlands. His academic journey is decorated with fellowships from AICTE, NDF, Government of India, and DAAD, Government of Germany. Dr. Balamurugan has authored 3 books, published over 55 research articles in peer-reviewed journals, and presented more than 20 conference papers. He has successfully carried out projects worth 12.2 million funded by national and international agencies. Under his guidance, 6 PhD, 6 MPhil, and more than 83 postgraduate degrees have been awarded. Beyond academia, he has organized numerous workshops, seminars, and outreach programs on disaster management, climate change, and geospatial technology. He actively collaborates with state governments to develop disaster management plans, disaster response strategies, and resilience frameworks. His current research interests span hydrogeology, sustainable development, climate change in water resources, geological mapping, natural hazards, risk analysis, and environmental impact assessments. Before we begin, I would like to take a moment to express our sincere gratitude to Mr. Suresh Mariasulam for his continued support and cooperation. His commitment has been instrumental in sustaining the spirit and success of these weekly webinars, and we deeply appreciate his contributions to the AABN community. We are indeed privileged to have such an accomplished scholar and practitioner with us today. Please join me in extending a warm welcome to Professor Guru Balamurugan as he shares his insights on geospatial approaches to seismic hazards and their impacts. Thank you, and over to you, Dr. Balamurugan.
Very good morning. I grateful to Annamalai University Alumni Association for giving me that wonderful and excellent opportunity. We had a long discussion about this talk, and I thankful to Mr. Kobi as well as Suresh Mariasalum who given me the opportunity to talk, because last month there was a big earthquake happened in Venezuela. Then before Myanmar, even different part of Indian subcontinent also experienced that earthquake. Apart from that, across the globe is severely affected that different part of earthquake and their damages and cascading effect like landslide and other thing. In 2023, Turkey and Syria earthquake, 2011-12 Japan earthquake. So we can talk a lot about the things. 2001 Gujarat earthquake, 1994-96 time Maharashtra earthquake, Okay, so these are the different part of earthquake. Earthquake is a part of a geological hazard, which we cannot stop in the process. Okay, just to give me a time, I will share my slide. My screen is visible.
Not yet, sir.
Got it?
No, sir, not yet, sir.
Okay, it's a processing system. Now?
Yes, sir. Yes, sir.
Okay. So thank you once again. Thank you very much. Today we have discussed about the overview of earthquake, introduction of the earthquake, and their different waves and their characteristics. So how to measure the earthquake, how we can use the geospatial technology in earthquake studies, and the earthquake early warning system, and what are the challenges based. Because the earthquake early warning system, anyhow, I will discuss in later part, but I give the clumsy. Many international level, many countries, they already well established a tsunami early warning system. But however, earthquake early warning system need to be developed. Okay, that we'll discuss in later part. This is overview of earthquake. So why earthquake is important? Because if we are looking any kind of hazards like flood, rainfall, or cyclone, volcanic activity, we are having well-established system across the globe. Okay, for example, in India, after 1999 super cyclone, which hit very badly, affected the state of Odisha and part of West Bengal, part of Andhra Pradesh, even Tamil Nadu coastal line also affected. But after that, Odisha state government and central government jointly made a early warning system, especially for the cyclone. So we are having very sophisticated cyclone-related, flood-related, monsoon-related forecast system. Even developed country, of course, European and USA having well-established system, especially in the meteorological related hazards like cyclone, hailstorm, and other things. But landslide, if the landslide comes due to the heavy monsoon, we can have the mapping and all. But earthquake related one, which is used to happen very quickly without any warning system, it's hitted, and we cannot be able to how we can say predict well in advance. However, in the geologist and the geospatial technologist had the experience, and they can able to identify the possible area going to get impact by the earthquake. But when, at what time, how, these are the things are again still it's a question mark only. So if you are looking at red color one, every day we can able to see the earthquake. But if you are coming the yellow color, green, cyan, yellow, light blue, and dark blue, these are the earthquake comes. Then only it is
I
great.
think
The
slide is not.
no,
this.
I am first. I am seeing that overview of earthquake. It is there.
Okay.
Okay, I am still talking about the overview of the earthquake only. So here I want to emphasize now every second, any one part of the world experience the earthquake, which is indicated red in color. But whatever you are seeing the blue color, these are the earthquake used to occur in the beyond, or we can say more than 5.5 in Richter scale.
Dr.
Now,
Bala, we are seeing only the
yes,
intro
sir.
slide, Bala.
Yes, sir.
We are
Yes, sir.
seeing
I'm
only
moving to the No, I moved to the overview of earthquake, third slide.
slide, Bala. We are seeing only the first
So,
slide.
now it's moving.
No, sir, it's not moving, sir.
Okay, just now.
No, sir, no, sir.
So overview of earthquake, the global
Maybe
image.
you can stop sharing again. You can share one more time, sir.
Okay, okay, okay. Now?
Yes, sir, yes, sir.
Okay, okay, okay. Okay. Now, okay, I think everybody can able to see that. Okay. Now, see, when you are looking at the earthquake across the globe, how it's a quite interesting, why that the earthquake forming and that thing, because the earthquake formed due to the different plate movement that takes place, because now we are having that 7 continent, each continent is moving different direction. For example, if you are thinking that the Indian subcontinent, it's moving north-north-east direction from south-southwest direction. If you are looking at Australia, it's moving from north-northwest to south-southeast direction. So every continent is to try to move the different direction because of the convection current, which is heat energy is producing the core, and it reaches to the mantle, and further it reaches to the still the asthenosphere. Because of that movement takes place, so these kind of plate movement takes place. And if you are looking at the current, especially last 5,000 or 6,000 years, the plate movement is not rapidly changed like what used to happen in the around 65 million years or 40 million years back. Now you can see this is the image which shows the overall image of we can say the number of earthquake happened last we can say 110 years, magnitude and the earthquake per year. So if you are mainly talking that the earthquake is reduced, whether it is related to climate change, whether it is related to anything, no. It is totally full and full related to the geological event. That too, it's mainly depends upon the convection current and how the plate movements are moving one direction to another direction. Okay, this solely responsible of the full and full geological component. Now, we discussed about the convection current, because before moving to this one, I would like to have an example of this one. Everybody know the convection current. Okay, I will give you one small example. Suppose you are keeping in milk in one small container, we can say basin kind of things. You pour the milk, you are boiling it. After it reaches a certain temperature, the milk get warmed up. Further, if you are increasing, that milk start boiling. You can see that the boiling comes from the center, and that things moving towards center to outside. Okay, when it is moving center to outside, the same way the earth is an inner core, outer core, this whole area called as a mantle, and this is the area called, we used to call as a crust, then asthenosphere in between the mantle and the crust. So when this kind of convection current takes place, one place the movement is detached. We can say that that is a divergent boundary. When the detached happen, some other places also the boundary comes out. For example, you can say this place. this moving towards this direction, this movement takes this direction. So here we can able to see the subduction zone are convergent. Two boundaries are coming together to make it out. See, one side is splitting here. See, this direction moving towards this side, this plate moving towards outside. So here opening is coming. We used to call it here mid-oceanic ridges. It's happening in the ocean side. Here it is this ocean floor and this is the continent floor. Ocean floor and continental floor, best example is in the California, where one side ocean floor is hitting towards the continent plate, so that a mountain orogeny happened. Best example is California. Another one, sir, whether we can have the continent plate, two plates are colliding now. Yes, of course, now it is colliding. Best example is Indian Himalaya, where once upon 65, 70 million years before, the India was big island, floated in the ocean. It's moved towards the northeast direction and hit it in the Eurasian plate, collide with the Eurasian plate. Then mountain orogeny generates. Then it's create the Himalayan. Now we are having the Himalayan mountain orogeny. The same way in Italy also we are having, and China we are having, Russia we are having, USA we are having the different kind of mountain orogeny, which is formed due to the continent to continent or ocean to continent convergent boundary. Now, if suppose or earthquake, there is no earthquake, that means we are having the there is no convection current, there is no heat movement happen in that core. If there is no heat movement happen, the entire Earth system will be disturbed. We can say that Earth become a dead planet. Okay, so this also important for that, but that is a different aspect. Now, what are the largest earthquake happen in the across the globe? Okay, so if you are looking at the last 50 years or 70 years back, the topmost, highest one. So the first one, if you are looking at magnitude 1960 in Chile, a 9.5 Richter scale earthquake. Then if you are looking at the second one, it's Macken in the Alaska 1964, 9.2. Third is in Indonesia, 9.1 in 2004. It's a tsunami where it's hitted very shallow earthquake and hitted the entire Indian Ocean, not only affected by India, Sri Lanka, India, Indonesia, South Africa, and many more countries got affected in 2000. This is where many of us victimed, and we saw what kind of damage occurred due to that Sumatra Island earthquake. It happened in the December 2004. Then fourth one, it's happened 9.1 in 2011, Japan earthquake, March month, where it's very badly affected in Great Daihaku earthquake. It's severely affected. More than 15,000 people lost their life, and million people were displaced, and this thing happened in Japan. And fifth one, if you are looking in Komata, Russia, even recently also earthquake happened 5.4 Richter scale few months back. So this is the way that different part of the world is to experience that highest to lowest earthquake. Okay, so you can see that all the highest earthquake things happening in the across the globe, and it gives the very bad impact to the not only the human, the property and other things. Now, how we are measuring the earthquake impact or magnitude and other things? So first we have to understand that earthquake is measured in two ways. One is magnitude, another one is intensity. See, what is the magnitude, what is the intensity? Okay. So I used to give this example to my students that before going to the seismogram and other thing, intensity, magnitude same, but intensity play a major role, which is giving the impact to the environment and the human and other properties. So for example, if you are keeping the hand like this, and you are beating someone with the same force, the impact may be different. Suppose I am keeping, instead of my hand folding, keeping like this, I am holding on small needle, force is same. Now my area size, you have to understand my area this much. Even I can make a small, the people can able to tolerate. But the intensity is very spark. The intensity is very sharp. Suppose I am keeping the needle in my hand and I am giving the same force. It is puncture the human skin. Now I come to the point related to the earthquake. Earthquake magnitude same, but intensity differs with the depends upon the rock as well as the lithology and the particular area. For example, if you are looking the earthquake, if occurred 5.8 or 6.1 in Japan, where they are adapted extensively the building code and the students were well equipped and well trained with the earthquake prevention and precaution method, they are well versed. But if you are taking the same example, some other part where there is no such kind of building code were adapted, the people doesn't know that awareness, we can able to get lost. We can expect a lot of damages and life loss in the such kind of place where the people never implemented the earthquake building code and the training. But in the case of Japan, people will save their life and they can overcome from that impact very short time. Okay. Now come to the point. In Seismic, almost this kind of technology developed 200 years back. This is called seismometer, seismogram, where they are measuring the earthquake. We can see that small spring is keeping in that ideal location, and weighing is there. It's keeping one pin. Based on the accelerated vibration, that rotating drum is measured. This measured, we used to call it it is measured in the Richter scale or Richter scale, and the Richter scale is coming from 1 to 10. So depends upon that magnitude, we can consider what kind of impact is there. Okay. Sometimes that magnitude same, intensity differs place to place. I already discussed how that intensity decide the rock type. Suppose the earthquake comes in the massive hard rock area. People used to say the arcane or cratons. The cratons area, the earthquake, even the waves passes the P wave, S wave, and love wave, even it is passes, the rock withstand that thing, absorb it, and it's not giving that much impact. Suppose if you are taking the sedimentary rock, very soft rock type, like Turkey, earthquake happened in 2 years back, it's giving major impact because all the things are limestone and other thing. When it is hit, it's giving very bad impact. So the lithology and the locality also play a major role to what kind of impact that particular area is experienced in the post-earthquake situation. So you can see that here earthquake magnitude scale 1 micro, 2 micro, 3 micro. So these are the things now till 3 or even till 3.5, only instrument can able to measure it. Sometimes we can feel it, small shock is to happen, small shock. We can able to see is very sensitive, we can able to see the small shock. But 1 to 3, very difficult to observe by the human, only instrument can able to find out. If you are going to make it 4 to 5, sometimes we used to get the newspaper, some tremendous, some earthquake waves comes, people are coming out from the home and that thing. So these things we can say 3.5 to around 5 Richter scale. And we can say the 5 to 6, the earthquake comes, even we can, if you are, the building is strong enough, if you adapt to the building code and other thing, building may shake, vibrating. We can able to see the vibration of the building, it won't get collapse. But if you didn't follow the proper building code and there is no proper mechanism, things are there, then it's a problem. One of the example I used to share, in around 1994-90 range, that Latur earthquake happened, most of the houses are the mud houses. So when the earthquake hit in that area, it give the major damage that part. Okay, so earthquake also, it's giving major role when that earthquake happened, whether it's a night time or daytime. Okay, so for example, in 2001 earthquake happened in Gujarat morning. So that day is a Republic Day. most of the people are prepared to celebrate the Republic Day celebration. So many of them are standing outside. When that even that major earthquake hit in 2001 in Kutch region, there is no much human loss. Property loss, of course, but there is no much human loss. But if you are looking at 1994, 96 earthquake later, many human loss happened and damage also property because at the night time happened. So many times when the geologists used to study about the earthquake, whether it's a night time or daytime also play a major role, especially the loss of human life. Okay. So now I come to the point that magnitude scale, the strong earthquake happened in the 6 to 7, where the building and other things are collapsed, and a major earthquake above 7 to 8, and greater earthquake if it is more than 8 to 10, it's giving the devastating earthquake. Okay, it's very difficult to withstand any kind of building, and that it's rarely used to happen. But one thing I'm telling you, without earthquake, without plate movement, we never get the seventh continent. Once upon a time, the entire landmass became, it was a single landmass. Due to that plate movement and tectonic activities, again it split, again it's collide one, then again to split into two, Laurasia, Gondwana, then further is split to 7 major continent. There are so many pieces of the islands are there, more than 200 islands are there, which was once upon a time, it was all together as a single landmass. Now we are having different part of different portion of the landmass due to that plate tectonic, you can say, or tectonic activity, or continental drift. These are the different terminology they are using. These all happened because of any plate movement happened. Of course, there is a earthquake. But one thing, if the plate movement takes place, the divergent one, we cannot get that much magnitude. But if the convergent and transverse, then always there is a friction is to happen. Now, earthquake comparison. Okay, average number of earthquake we can say. This is the I want to share this one. How much energy is released for every earthquake? If it is the scale is 2, in the Richter scale is the magnitude is 2, and then that amount of energy, okay, TNT, we can say detonator. This much tens detonator, metric tons detonator, 300 tons metric tons of detonator, we have to use it. Then only we can get the 2 magnitude of the earthquake. The same way, if somebody want to, some earthquake happen in the 5, we can say 95 lakhs tons of detonator, we have to use it. Now, if you want more 6, we can multiple that much million metric tons of detonator, we have to use it. Okay. Now, if you are looking that one, you can see that 300 to 9,500, 9,500 to 3 lakhs, 3 lakhs to 95. Okay, 3 lakhs to 95 lakhs. All the scales are in the logarithmic scale. Same way, the magnitude also, 2 to 3, the values are looking simple, but this is the logarithmic scale. 2 to 3 is not a 2 to 3. It's a, if we are seeing that 1, 100, 1,000, 10,000, lakh, 10 lakh, crore, 10 crore, like that it will go. It's all the magnitudes are the logarithmic scale. That's why, suppose I want to give one example. If the earthquake happened 5 and 5.1, 5, 10, 100, 1,000, 10,000 lakh. So 5.1 means it's not a 5.1 lakh. It's a next level. We can say 2 lakh, 3 lakh, 4 lakh, 5 lakh. We can go, this is that logarithm scale, because these two, this is the 10 lakh. So we have to understand that logarithm scale, that magnitude, as well as the impact also, that much amount detonator they have to use it. Then only we can, that earthquake can produce that much impact or magnitude. Now, magnitude versus the intensity. Okay, so it's quite interesting because magnitudes have one magnitude, the intensities are many. For example, 5.1 earthquake happened in the hard rock area. It's a granite. The magnitudes are different. The same way, if that magnitude 5.1 is happening in the soft rock, the intensities are different. Why? Because the intensity varies from the earthquake epicenter to other side. If the epicenter is there, okay, suppose you are an example, one particular place is the magnitude earthquake happen, that is the epicenter. If away from the epicenter, for example, earthquake happened in XY direction, okay. For example, we can say 2001 earthquake happened in Gujarat. Tamil Nadu, we didn't feel any kind of shake, but Delhi and other by person were experienced. In 2001 to Chennai offshore area, there was a small earthquake happened. Where the Chennai, many people part of Chennai and other people experienced. In South, we didn't experience anything. Okay. Same way in Himalaya, earthquake happened when I was in Leh Ladakh. The earthquake I experienced, but in southern side they didn't experience. So the intensity is more and more very close to the epicenter, where the intensities differ in the away from the epicenter. That one only we have to understand very clearly. Okay. So earthquake waves. So how that earthquake waves are moving? So we used to say that P wave, S wave, and L wave. P wave is primary waves. So when we are having nowadays, we are having the sophisticated instrument, we can able to measure that how much speed that earthquake waves are moving, and how much area used to get disturbed. What are the objects that we can able to move? This all we can have a look. So when you are having that earthquake boundary, because across the globe, every place they are having the seismograph to measure the earthquake intensity, to measure it, what kind of direction the plates are moving, how much energy is releasing, what are the consequences. That's why some places the people, scientists are telling there is a high chance of near future, one particular location, earthquake may going to happen, maybe 2 years, 3 years down to the line. Okay, so the people used to have that precautionary measures depends upon the early warning system. Okay, now you can save that example. This is the focus indicate the earthquake takes place. Okay, this is the North Pole, South Pole, East, West, North, South, East, West. And if the earthquake is hitted here, this is the crust and mantle, this is the core. So when that wave hitted, the P wave is coming here till 103 angle. Okay, it's not passing the whole area. It's passing, we can say from the location to here, 103 degree angle deviation location only, it will pass it. Okay, you can say this is the 90 degree. Okay, this is the 90 degree triangular. We can say the triangular till 103 degree only it comes. It is not able to pass through the core of the earth. So we are getting this area we called as a what? We used to call it a zero zone. So we cannot pass the focus. Okay. So that's why they are taking P waves generated at the focal point, travel to the earth. We represent the path that we follows that rays. These are the rays, earthquake rays. So these are the rays B's where we can able to feel it, but we cannot able to measure it. Okay, we cannot get any exact. So we whatever you want to focus, we can get it from the this region only. Okay. And now what are the characteristics? Okay, one we talked about the P waves, another one is the S waves. Okay, P waves is movement of the P waves, movement of the S waves, movement of L waves are different. Okay, primary waves passing the vertical and other thing longitude direction. S waves are the transverse version. L waves are longitude and horizontal, both it is there. Okay, so for example, if you put the stone in the top of the water, what happened after stone going inside the water? The waves are forming. Correct? It's a waves are forming, and it start originate from the center, and the waves are propagating the outside. Okay, if you are looking at a small basin or even open well, you drop the center point one stone, it's creating the waves. Correct? Stone went down, but it's creating the waves. The same way, some way it is moving like this. You can able to see that waves moving. Some waves moving the horizontally. Okay, so this is the way P wave, S wave is moving towards the ground. S waves, we have to say that shear wave travel into the earth, but shear waves cannot pass through the liquid. Okay, so that is the uniqueness of that S waves. That's why primary waves passes first, secondary wave second, and liquid it is not passes through liquid, and that cannot pass through the outcore. So if you are looking that is the core, earth center core is a mantle and crust area. This created the large S-wave shadow zone compared to the P wave, and it presents this shadow zone that proves that the existence of the liquid in the core. Okay, so how you can say that center of the earth is having liquid and other thing, and mantle, some part of the mantle we are having the liquid, because we can say that volcanic eruption, liquid form only it comes out. All the lava flow used to happen, it's a liquid form only. Okay. Now, just this you want to have a look how that waves are forming, how that people are measuring that earthquake in that way in the geologist and geophysicist. And I would like to share this example because how that magnitudes are measuring the earthquake and how they are taking that P wave and S wave. This is the example of P wave. We can able to see that P waves and S waves, these are the depth in kilometers because this is the center part of the earth, this is the surface of the earth crust. So this is the horizontal distance. We can say that depth, how it is measuring. We can say that it's a epicenter starts, the P waves first comes, crust. It is not having the uniqueness of travel and the characteristics. Okay, you can say that beyond the S waves, this is P waves are passing through all the layers, but S waves not outer core is not passing because of the liquid. And you can have a look. These are the different characteristics, P waves and S waves. Okay, their velocity is different and their characteristics are different. Okay, so it is not. Some of you are not from geology background. Please ignore it. But there is a earthquake waves are there, P wave, S wave, and L waves. And how that why we have to understand this one, because earthquake is not happening only surface, it's happening in the subsurface. If the earthquake depth is shallow, of course that impact is very huge. If the earthquake depth is very deep, the impact also not that much. Okay, until unless the earthquake magnitude is high, the intensity becomes less. Why? Because the thickness of the earth, that crust, that will manage the impact in the surface. If the shallow, it will reflect immediately. Now, hypsometric curve of the earth, why we are giving this one? Because we have to understand that oceanic floor or oceanic crust and continental crust. Oceanic crust thickness is less compared to the continental crust. So that the impact is the more in the oceanic crust compared to the continental crust because the thickness is the continent portion is more. And this is the cross section. We have to understand that how that divergent boundary is happening, and these are the points where volcanic arc is to happen, and mid-oceanic ridges, and these all landforms formed due to the plate movement. The plate movement is to happen due to the convection current. The convection current formed due to the heat of the earth core that it passes through the mantle, then it's making the convection current. Okay, so this is, I want to share that plasticity and friction, how it is made. Okay, if it is that hard rock, suppose the earthquake happened in the hard rock area, the impact of course less. If it is the soft rock, the impact will become more. Now, the earthquake seismic layer and Rhyolic layering, we have to divide that. Now, seismic wave is very important to understand the subsurface. Okay. For example, this is not related to this title, but I just given an example. Seismic wave, they are artificially sending the seismic wave. We can say gamma ray and other things for hydrocarbon exploration and deep ocean studies. Okay, to understand that presence of hydrocarbon and different depth of uh, sedimentary layer and other thing. So we used to send that artificial seismic waves. Okay, using gamma ray and other things. Okay. Now, I would like to share this one in earthquake happened in Turkey. How it is happened, we can have a look. Okay, I'm sorry, I'm unable to play the video. Because recent earthquake we have taken, this is the USGS, United States of Geological Survey. United States Geological Survey, we have taken that a lot of material. Even we used to get from the IMD. So internationally, USGS, United States of Geological Survey, and IMD, Geological Survey of India. In Indian concern, they are giving the authenticated data for the earthquake, not only India, nearby Indian subcontinent, and USGS is giving that overall information. But rich information we can get it, especially in the USA, South America, North America, and nearby regions. I just taken that there is a lot of filters are there. Yesterday, while I was preparing this one, I just want to see that what are the recent earthquake happened and latest earthquake happened. They measured. They are making the 11th July 2006, 2026. There is a earthquake happening in the Philippines and the nearby area, and they are giving the whole detail. It's an interactive tool. We can able to use it and show that. Okay. And Myanmar earthquake happened in 2025, and it's giving a huge impact. Why it happened? Because of the convergent boundary. And as a geologist, what I used to say that it is a Turkey earthquake satellite images, because I want to share that when the earthquake happened, three different type of movement used to happen. Okay, when I explained, one is convergent, where two plates move together and collide. Another one is transverse, horizontal movement like this. Third one is divergent movement. So divergent movement, it won't give that much impact. For example, recently everybody knows about the African continent is split into two. Okay, it created a big canyon. Okay, big opening, no impact much, not much impact. Only that land portion is split into two portions. But when the collide, okay, for example, accident, the two vehicles are there, it's coming out, no problem. But two vehicles are collide perfectly, 180-degree angle, it's a collide. It's created a huge damage because the speed of one movement and another one is resistant, or both are moving together and hit it. And it accumulates a lot of energy. How the earthquake formed? Because suppose you are hammering the one iron plate, once you make it, it's giving the vibration. Okay, another one example, temple or church, what they are in, they are giving the bell. Okay, but if you are after ring the bell, that we can feel the sound comes. The sound comes because of the vibration. You just touch the bell, the vibration loss, because that vibration absorbed your body, we can feel it, the vibration. Okay, so the vibration depends upon the impact, the vibration will come. If you touch lightly, very low impact. If you touch very fast, if you suppose you ring the bell very fast, or very intensity more, we can able to see that now. So that vibration, so the same vibration used to happen in the earth when that both boundary collide, That is a convergent boundary, and it's giving the huge impact not only the property, it's an entire landmass. Okay. For example, I want to share this Turkey earthquake in last year. In the why I given the example of Turkey earthquake, Indian earthquake also happened. It's giving lot of impact in 1952, 1950s Assam earthquake, 1935 Patna earthquake, 1994, 1956 time Latur earthquake, 2001 two-time Gujarat earthquake. Okay, every earthquake used to happen, but that Turkey earthquake is a unique earthquake because continuously 2 months time continuous earthquake happened in the different part of the Turkey and the Syria region, and all three different type of land movement is took place. Divergence also to happen, convergence also happen, transverse also happen. This is the example of divergence. It's a canyon formed where the plate were moved and depression formed. Okay, but these places there is a movement happen, but there is no damage of the building and that thing because the landform is split in two. But other places where these are the places where the vibration convergent boundary happened and that thing. Even that video, sorry, I'm unable to play here. That video shows how that one earthquake make a transverse movement, and it's that one tree split into two and dislocated 30 meter away, not 1 or 2 meter. One tree, half trees one places, another half trees and some other places. It's split into two. It's moved. Okay, that is a good example. Whatever the earthquake movement and type of movement, plate movement, this we discuss convergent, diverse, and transverse. This all the movement is happening in the Turkey earthquake 2025 earthquake. Sorry, 23. Now we can see that example because that earthquake. I also put lot of some time to reference it. Then I felt that okay, this is the easiest example one can understand a better way about the movement. See, if you see at the earthquake 6 to 2023, it started again and again, and 22. Okay, within 10-15 days, there are so many earthquakes happening in the near region. Okay, if you are looking at Turkey, Syria, this is the landmass. This region is a convergent. Both boundaries are coming together. It's colliding. Okay, next slide, I'll show that one. But this region is transverse. It's moving towards adjacent. But this region is diverging boundary. So this all three junction we can, sorry, three different type of earthquake movement we can able to see there. Yes. See, convergent movement, divergent, convergent boundary. This is the major earthquake happened and a huge impact happened in this location. Transverse fault and divergent area. So these all the things happening in this region. Sir, how much time I can take further? 10-15 minutes?
Yes, sir. Yes, sir. Yes, sir.
Okay. Now, this is the satellite image showing that it's not a satellite image, it's a drone image. They prepare the contour before the event, after the event. This image shows the after the event. You can see that this region, the canyon formed, we used to call it a canyon. Canyon formed, we can say depression formed here. We can see that the line, this line, this is exactly this line, A to A dash. This line, we can say one line, the depression is formed here because of the divergent movement that takes place, and here also is a depression formed. We can see that before the event, that this is the before the event, the blue color, it's like this. After the event, the depression formed and elevation also formed because of the one side the mass moved, another side is deposited. So this is the way it is happening. There are so many photographs, but I feel that this is the good one. Why? It is giving the elevation. These all the lines are there now. These all the lines are contour line. So contour line is helping to understand the level of elevation in the area. Okay. Now, this is the satellite image in Myanmar earthquake. It's a Cartosat image. Our Indian satellite image is captured before the event. We can see that Mandalay University in this, after that building got damaged. This is the before the earthquake. This is the after the earthquake. Same way, before the earthquake, after the earthquake, you can see here. There is a, we cannot be able to see this kind of building over here. Almost 90, above 95% of the building were collapsed and damaged. And this is the recent Venezuela earthquake image. I took it from India Today image. We can see the before, how the beautiful city is. Okay. And now see that situation. Most of the buildings were on the down to the earth. Okay. Every building. Okay. We cannot be able to see any building. I saw more than 100 photographs to understand how that earthquake giving a big impact. I can say that devastated the region. Okay, most of the building, it's a huge damage and economic loss to the country. Now, I come to the point, earthquake in India, whether any part of in India is safer. People, we geologists, we feel that some craters are safer, but the entire globe, once upon a time it was under ocean, now it has become the continent. Whatever the landform, now it is under ocean. Once upon a time, it was the continent. So cycle is changing. Today is the continent. Tomorrow become the ocean floor. Whatever today is the ocean floor, after certain period, it become the continent. So why it happened? Because of the convection current. The heat comes out from the core and it's create the heat energy, making the convection current. And the convection current trigger the crust through astrosphere, then the movement takes place. Suppose somebody taking out the entire heat from the Earth's surface, sorry, not the Earth's surface, core of the Earth, the Earth become the dead planet. Because whatever the gravity, whatever the magnetic field, all the things will be lost. So once we lost the magnetic field, the gravity, everything, the near and the real characteristics of the Earth will last, so that we cannot be able to get any kind of atmosphere and other things. Now, this is the earthquake of India map. You can see that all the dark color, you can see that the Himalaya region, whole Himalaya region, and that Andaman Nicobar Island region, and a small portion here south, we can able to see that lot of earthquake point. This all indicate the earthquake intensity. If it is the big circle, major earthquake, smaller circle, smaller. So in India, before this is the latest map. Before that one, they used to keep zone 1, 2, 3, 4, 5. Now there is no 1. Now they are keeping 2, 3, 4, 5 only. So most of the area is earthquake prone region. We can see that all the earthquake region, the entire Himalaya, this region, some portion of Maharashtra and other thing. And the yellow color, we can see that all over the state. We cannot say any one state is safer from that. All the states where we have to prepare well for our earthquake resistant building, earthquake early warning system, and all other things we have to keep it. Okay. Now I come to the early warning system. In the government of India, Ministry of Information, we can say that the earthquake multi-hazard early warning system is there. For example, a cyclone, flood, rainfall, hailstorm, and other things. But there is no single, even tsunami we are here. Well-established tsunami early warning system we are here. But we don't have the early warning system for earthquake today across the globe, not only in India, across the globe. That's why you can say here it's a multi-hazard, MHEWS, multi-hazard early warning system, decision support system. Okay, so multi-hazard early warning decision support system, they are having multi-hazard. Mainly, they are focusing 3 different components. Okay, that I will discuss later. Now, multi-hazard early warning system, how this system is works. They are capturing the information from the satellite data. and they are collecting, continuously monitoring the information from the satellite. How I am giving the satellite, why it is important, especially if we are talking that a meteorological related hazard. They are very precisely measuring the ocean surface temperature. Okay, ocean surface temperature is very, very important, which is essential to understand the climatic variability in the local region. So very micro level, they are collecting the information, then they build the model and they run the model, then they are giving the forecasting that especially the cyclone depression formed or only cyclone, or it's giving the rainfall, or it's giving what kind of impact, or speed of the wind, everything they will give after the landfall. Then after collecting the information, then integrated the satellite data, radar data, ground-based data, everything they're making. And after that one, they are keeping that nowadays AI and so sophisticated system is there, and they are disseminate the information through that cyclone, flood, and heat wave or marine events. So they are making, for example, high tide. If somebody is there in Mumbai, they will give the proper element system, the high tide, and I think in the coastal area also they are giving the high tide. The same way, cyclone depression formed, cyclone or rainfall is going to happen. This all the information. Okay. Now multi-hazard system, but they are keeping only two agencies involved. One is Ministry of Earth Sciences, another is IMD department. Okay. ISRO is part. ISRO is giving the full support to them, but they are disseminate the information from the Ministry of Earth Science or IMD only. Okay. Even though satellite launched by the ISRO, they are disseminate the directly information to the IMD. IMD only giving this information about the earthquake, about the rainfall, and all kind of information. Now, if somebody would like to have an idea, who is the agency in India to give that information about the earthquake? IMD, Indian Meteorological Department, and also supporting departments are Geological Survey of India and the Ministry of Earth Science. They are directly involved about that earthquake related thing. Okay. Not only IMD is giving the data about the rainfall and the flood, cyclone, and all. They are giving that this information also. Apart from that, some IITs, some ICER, some central university also having the facility to monitoring the earthquake their own capacity. Okay. Now this information comes from the Press Information Bureau of Government of India. They are giving in 2021, stating that these are the places where high risk. Okay. State cities, all the cities, and Andaman entire region is the high risk, highly prone to the earthquake. Okay, we can say that the cities zone 5 to 6, all the region they declared as the earthquake zone. Okay, these are the important location they given. We can say that 59, approximately 59%, almost 60% of the landmass prone to the earthquake, or different kind of intensities. Okay, now you come to the point when I shown that Indian map and India map, different level of earthquake. The government they have declared that approximately 60% of the land mass is prone to the earthquake related, and they are giving. So you can see that almost most of the part of the earth is Indian land mass is prone to the earthquake. Okay, the intensity may varies. But most importantly, because I given that challenges. Okay, first I read it and I'll give the challenges, and then I conclude my talk. Bureau of Indian Standard, BAS, BMT, PC, Building Material and Technology Promotion Council, HUDCO, Housing and Urban Development Corporation. They are well developed manual they are having, building codes. If the earthquake prone area, what kind of building codes, what kind of building they have to construct in the earthquake zone 5, 4, 3, 2. They have well nice plant. It is there, it is available. Guidelines are there. But presently, no proven system exists in the country to provide the early warning of earthquakes. Moreover, there is no scientific techniques available anywhere in the world to predict an earthquake precisely in terms of time location and its magnitude. We have to understand this one. Okay. Nowhere the world, nobody can understand. Even some of them, they are discussed whether we can able to measure the earthquake comes and we can measure it. Not possible. But earthquake not possible. But tsunami, we can able to give the early warning to the nearby area. But the intensity of the tsunami may differs when how much energy it carries. Okay, tsunami early warning system is existing in India and a different part of the world. Please don't get confused with some of the audience. Early warning system of earthquake is not yet developed, but earthquake induced the secondary hazard like a tsunami, landslide, and other things. Those things we are having well-versed technology system to predict and prevent that the tsunami and other thing. But we don't have the system for earthquake. Okay. So this information is given in 2021 by the government of India. Okay. I conclude my session here. Thank you very much. Thank you, Ananta.
Thank you very much, sir. Great session. A lot of takeaways from it. We'll now keep the floor open for question and answers, sir. Can we start with Professor Moni?
Very good morning, good afternoon, Dr. Balamurugan.
Good morning, sir. Good morning, sir.
And thanks to Mr. Gopi, we are having every Sunday this knowledge, dissemination. And after listening to your talk, I feel that I should come join Central University for a 3-month course.
Yes, sir. Yes, sir. We already used to discuss a lot about the other component with Suresh Mariusala. I grateful to him and I grateful to you, sir. Please, sir.
And it is very important that you have given a thrust and understanding, and like Japan, they are so conscious, and India also should move towards that, because Japan is less populous, India is high populous, and if any destruction of even less magnitude, intensity will be high of damage. That's how I understand. And I think in every higher education institutions, whether they teach geology or not, they must be teaching geography related things. That I think a special course has to be introduced, maybe with the new education policy, some sort of a credit course on earthquake based on your presentation is a must, so that the undergraduate students should be in a position to understand and take the credit towards their degree. And I think it is not confined to one university, confined to some good few professors. And this magnitude of the problems which you put it, I think everybody has to have a good general knowledge about this area. They should not, say that it's a geology study and so on and so forth. It is leading to destruction. So we have to, contemplate, we have to prepare ourselves and so on and so forth. It's good that you gave the answer given by the Honorable Minister in Parliament. That gives an assurance that this is what the ground condition. And I thank you, Dr. Professor Guru Balamurugan, and it's a very good presentation. But don't leave it with the presentation on this Saturday under the chairmanship of Mr. Gopi. I think we have to convert as at least a minimum 3 months online course, so that not only the ongoing students in the campus, also the people outside the campus should be able to understand. It is a must. And since you are from a central university, I think you should be able to have this journey very effectively. I think today I thank, even though I joined 15 minutes late, but I thank, your presentation. It is completely technological, completely scientific, research oriented, and we have to keep it up, because you will keep it up, but people like us, we are working in multi-dimension, and we have to keep it up. That's why I thought that I should join you as a student for a 3 months an online program. Thank you very much. Thank you.
Okay, sir. You say can I respond now, sir?
Yeah.
Yes, yes, sir. Please go on.
Sir, very interesting point you have given, sir. For your kind information, Central University of Tamil Nadu, we are offering a UG level 2 credit compulsory course for disaster and disaster risk reduction course, where these common are also part of the course. So all the UG students, it is a mandatory, they have to study 2 credit course. 30 hours we are teaching, sir.
Yeah, but don't confine to only to the your university, and you have to expand that
Yes.
all
Yes,
the
yes, sir.
state universities, and your networking central university with networking with the state universities are very important, at least to start in Tamil
Yes,
Nadu.
sir. Yes, sir.
Because
Yes,
in
sir, yes,
every
sir.
state has got a central university, they cannot work, they cannot function in isolation. So I think this course, I think you should publicize it and take it up with the government of Tamil Nadu, that and UGC or All India Council of Technical Education, that this course is very important. And
Yes,
if
yes.
you have an 3 to 4 credits or whatever it may be, but let the other students also put, because I'm telling you, many of the private engineering colleges, getting a qualified professor like you is very difficult, and especially self-financing colleges, and where your involvement, central university involvement, will make a big difference. I think you should become a mentor for all the private engineering colleges in Tamil Nadu. And students should get benefit out of it, because they're studying in private engineering colleges, where getting a faculty member is a big issue, because this is a highly qualified faculty members. So I think if you can make it that central university will offer this course, and under the new education policy, whether the state government has accepted or not, you make open that all the engineering graduates under this one, they can opt for this course. And you can, my request will be that publish it in the newspaper, so that and write it to all the private engineering colleges and state engineering colleges, and those who are offering MSc programs in geology in general colleges. I think it will be a big movement which you will be taking it, and we can see that convert Tamil Nadu as a Japan with respect to earthquake understanding. That's how I view it after listening to your talk.
Thank you, sir. Thank you, sir. Yes, yes, sir. We actually we are requesting the UGC to provide the grant for developing this course for online open to everyone. Hopefully, we can get soon, and otherwise also we can. At least I can create some of the videos, since I was working. Sorry, I was working to 2 years in Tata management. I'll give that awareness video of 10 minutes, 15 minutes for a different hazard, early warning system, how to secure oneself from such kind of impact or hazard comes. I will put some video in.
No, my view is that now let us take this into an action plan. And I feel a strong one. I think my request to Gobi sir is that please issue a
Yes,
press
sir.
release. Please issue a press release and let it go in the social media based on today's discussion. This webinar is conducted on this topic, and so and so delivered a talk from Central University, and it will have an impact, and a course is available, and students can join for this much credit course and so on and so forth. Because like organization like yours has to take the lead role of passing this one through social media in a very big manner. My request is with input given by Dr. Balamurugan, kindly issue a press release. I think every webinar seems to be very important. And let us make maybe that after 200, 300, 400, After every 100, you should be able to release a book release based on this. It will be very good thing that. Okay, thank you.
Yes, thank you, thank you. Dr. Kadaresan? Dr. Kadaresan?
So no questions, sir. No questions. Very nice.
Yeah, Muthukumar sir, Rajendra. Mr. Sanjana?
Good morning, sir. Thank you for giving that I would say admiration and that opportunity for me to speak. Thank you so much, Dr. Guru Balamurugan. If I'm mistaken by for pronouncing your name, because
No,
I'm
no
very
problem, no
versed
problem. It's correct only.
with South Indian names. So thank you so much for today's very intense, technologically sound, deep presentation, sir. Of course, whatever I could understand, I could understand. But my question is, sir, how you think we as Indians are well equipped towards the disaster management, be it of any kind, not only earthquake, but for any kind, for that matter? How well we are prepared? Do you think we are prepared? So because you as a technical person, or you as a expert from this particular field, definitely you have knowledge, sir. But then, do you think on the ground reality, wherein we as humans or we as citizens, we have to deal with the, sudden situations like this when it happens, and most of the time it happens unannounced. We are not really aware that this is going to happen. So how well you think we as citizens, we are prepared? And if we are not, I'm sure we are not prepared, because none of us have this kind of a SOP to be followed, or things to be followed, what to do in such kind of a situations. So what can be done, sir? How we can improvise or educate citizens on a larger scale, not only college students or or school going students, but otherwise we as humans as wholes, or what we can do, sir, about it. Thank you so much for my question, sir.
Okay, thank you. See, I'm the disaster management field since 2008. Almost 18 years I traveled in the disaster management field. I would like to give few examples. When we discussed about the disaster management 2008 to 10, after 2004 tsunami, we have well-established system here having. For example, common person, whatever the technology we developed, without community participation, without the grassroots level, none of the things going to become the success. I am very strong believer of that. Any technology should reach us to the grassroots level, common people. Then only the system will be success. Otherwise, we can put only the paper. Now, I'll give few examples. Okay, one about the crop insurance. 20 years back, if you are looking that any kind of damage happened to the crop, government of particular state or center used to give the compensation. Now, most of the crop having the insurance before going to the seeding the crop, they are having the insurance. Any loss comes, natural calamity event happen, they are getting the crop insurance. Okay, that reaches to across the India. We can say more than 60-70% they are having it. Second thing, the community level preparedness. Whenever the disaster management preparedness goes, we always choose the community level preparedness, CBDRM, community based disaster risk management, or community based disaster risk reduction, CBDRR. These all the things that we are doing it. One thing we have developed and involved, not we developed, we involved the community based thing in the West Bengal, especially in Malda and other areas, the flood related. So they equipped well how they can come up from the flood related and other thing. Next one is the Kalimbang, community based, mobile based app they are having. they are giving the warning system from if the heavy rainfall occurred, they are giving the remote village people today this area is reducing maximum rainfall. Don't travel in the night time. Please caution while you are traveling in the hill region because of the high chance of the landslide. And some network project we submitted in the Ministry of Earth Sciences, where we plan to develop the community-based early warning system, where we are involved the community also. They are the one first responder. How to make it out. And next one is the awareness. So, for example, in the coastal area, if the persons are living in the coastal area, ministry giving the early warning system through mobile, different kind of message dissemination is there. One is since many of them are having the mobile phone, and I think they are giving the call, and they are giving the SMS, and they are giving the radio, television, all kind of form disseminate the about the cyclone and flood kind of related information they are disseminating. Even if you are traveling any places, you can that such kind of information is updated in the map also. So in finally, I conclude your question. About 60 to 70% the early warning system about the issue, the community is aware. Okay, but many places, what are the challenges we are facing? The implementation, ignorance, very difficult to make them to understand and other thing. For example, very high tide situation in Mumbai, when I was in Mumbai till 2020, high tide time, police personals and revenue department is giving the announcement, don't sit on the seashore, don't sit on the wall, or don't go close to the high tide. But irrespective of all, the peoples are going and sitting and enjoying the situation. But that kind of thing we cannot able to make it out. And the second thing, the attachment, the emotional attachment with the community, what they are having, the belongings under their particular location, it's very difficult. For example, even if you are asking me, sir, you come out from your home, it is going to happen. By some sympathy and attachment is there, no? That is not able to come out from my home. So this kind of emotional and so many is a multi-risk because multi-dimension one. It's very difficult to give the awareness. We have to, of course, we have to put lot of effort to understand about the community, and we have to give the awareness to the community. Then only it becomes success. We can say above 60-70% we succeed. Still, it is there because of the some emotional attachment, sometimes it's ignorance, sometimes the communication is not reaching exactly to the community what we want to communicate to them. So these are the challenges. I agree with you, but we improved and we are improving.
So thank you so much for sir for your detailed answer, sir. That really enlightened me. And sir, another question, sir. Like for example, in Assam, you have this Brahmaputra river, and every year the rains are also there for longer duration, for longer months, also very intense, and the area tends to flood a lot. And this is a very every year situation, and they are yet not able to find out any solution for it, and it really affects their population on a larger scale. Like the entire community is affected very badly. So such kind of what you say, every year occurring problems will ever have solutions, sir, which are very area specific. And are we really? I do not know whether it's the right question to you or not. But
No, yes, of course, because I have done a lot of study in Assam,
yes,
Majoli
yes,
Island,
yes,
Dhemaji,
yes,
okay,
yes.
Shivsagar to till south Guwahati, we have done a lot of studies. You can ask me because personally I was there in North Assam to higher Assam to lower Assam. You can ask me, no problem.
So I have stayed there, sir, for 2.5 years, and once
Where, madam? Which location in Assam? Specific location?
sir,
Majoli Island. I visited. I carried out the study on Majoli Island. I stayed more than a month there.
I know about Majoli Islands. It's very, I would say, very.
One
What
of
I can
the
say.
biggest, world largest freshwater island actually.
Oh, that is also there, and there are some mysteries also involved. There are some stories around Majuli Island, what I could recollect. But sir, I was in Rangapada, sir, in amongst the tea gardens.
Okay, okay, okay.
It is surrounded by all tea gardens near Tejpur. So we
Okay,
were
okay.
there. So once we were traveling as a family. I was traveling with my small children. My younger child was, a lab baby, and we were supposed to catch a flight.
Oh,
And the flight was early in the morning, so we reached somehow. It was rainy season and this and that, so roads were flooded, this that. But we could not even reach the airport, sir. We had booked a guest room. We could not even enter the guest room. We could see it, but it was so flooded. If we would have entered the water, our car would have submerged. So we had to wait in the car itself. And this is the scenario every year over there. And like, forget about us, people like us who sometimes go, or for a few months or few days or few years. But people who are staying there, this is a constant problem. Every year they face it, and that too for a longer duration. The rainy season lasts a little longer, almost around 7 to 8 months. So is there any solution, sir, or have they found any solution for this? An entire
ma'am.
state is affected very badly because of that.
Okay. Can I respond now?
Yes, yes, sir.
Okay. So since you experienced that Assam, we should always respect the indigenous knowledge, Indian knowledge system. If you have looked very carefully about Majuli Island community, missing community, and other people, how they are making the house, bamboo house, at least it depends upon the water level, their height, the house height. There is no concrete platform. Every a pillar is made by the strong bamboo tree, and the above the surface, at least 10 to 15 feet height above the surface, they are doing all. But unfortunately, because of the climate change, adverse weather condition, and all, the level of flood and other things very bad. Okay, we should have the um, cumulative uh, assessment and early warning system and technology we have to develop to reduce the impact, because we cannot stop the impact totally. Come out from that all. What are the way? Educate the people. Um, uh, make it the safer side, how to shift the places. For example, we have a 1950 earthquake. Entire Kugamuk is shifted 6 kilometers from west to east. Okay, so these are the damages happened, but we have to give the awareness and all. And sometimes structural measurement will help, not fully extent, not that much fully extent. It is not possible also, because it's a very dynamic nature. Because the Brahmaputra River is in the near tectonic land. It is located in the near tectonic region. The whole region is prone to the landslide. Sorry, earthquake, and landslide is a high hill. Lower area is erosion and prone. So we should have the holistic approach to overcome from this issue through community, science and technology, and indigenous and Indian knowledge system. Then only we can overcome from the such kind of challenges and difficult situation. I am very open with that, because if you are asking that the very old people how they are managing it, even if in the Assam you can able to see that ambulance and other things are in the boat related. Even boat, I witnessed even myself. Some of the villages, they are keeping the mobile health center using the boat only. Some places. So these kind of things only we can able to manage it. Otherwise, it's very difficult. Especially what happened now that climate, now the people are talking about La Nina, El Nino. This all impact, it's giving adverse weather condition. It's a very challengeable. Okay, I also faced the same problem one time when I have to come out from the Demaji to the Burger airport. I suffered a lot. So it is there. It is there. Still, it is there. But I believe that the bridge they opened so that it is reduced the time from West Bank to Southern Bank to cross it within 1 or 1.5 time. but some kind of technology and capacity building with the community, and then only we can overcome from that. Not only that, I most importantly, but the whole Assam, we cannot go for the unique method. Every place, the communities are different, the level of risk and vulnerabilities are different. Based on the micro level management only, we can able to overcome from such kind of difficulties.
Thank you so much, sir. Thank you so much, Dr. Guru Balamurugan.
Yes, yes, ma'am.
Thank you, sir.
You can contact me, ma'am, anytime so that I can help you in this regard. No problem.
Sure, sir. Sure, sir. Actually, sir, it is not directly my area of interest. I'm involved in tourism. But then one of the scholars from the same region, Assam, we were discussing on the similar problems, sir. He was saying that, like, if I may talk over here, if I'm not taking too much of time, Dr. Gopi, can I talk for a minute or more?
Yeah, please go on.
Thank you so much. So we happened to discuss, like he was talking about his field and I was talking about my field. So the thing is, the elephants' encroachment or elephants coming to the human area or human habitational area, it's very often seen over there. So we were discussing like what could be the problem. So he said that all these they actually like eating what is that? Banana plant leaves and banana fruits and things like that. So that is getting cut. Because of that, they are encroaching the human habitats. So what can be done about it? So from the tourism perspective, sir, like we were on the discussion. So when we, as you talked rightly, that if you can involve the micro level local people, and he suggested that if they can plant more banana trees in the nearby vicinity, so that they don't have to travel from the local place or their territory to the human habited area. And another thing is we can involve local community. This, for example, local community can involve the tourist and that can be tagged. It can be a money making business also. Like tourists, they would like to get involved in the local community activities and they want to see the real life experiences. They want to do it like first hand experiences they want to experience or take. So the local government can actually keep a entry amount or something like that. And this plantation can be done through the tourist also. So it is going to be, you can say, inclusive approach from all the angles. So such kind of a rigorous thinking is not happening, sir. Actually, what is happening is for any problem in our country, we all are thinking in isolation. And that connecting the thread or coming together is not happening. Everybody is right, everybody is correct in their own manner, on their own approach, but then that collective efforts are not taking place. Because of that, no solution is can be seen, or we are not able to take appropriate or right action, because it involves everyone. You cannot just say that okay, this is the problem and this is how one needs to go about it. For example, technically, if technical person is there, so we require people who are actually community friendly, who are working with local community. Their involvement is also required. Then we require policy makers who can create such kind of policies and then come together. So it is a complete involvement of experts from all the fields. So this was one of the problems what we discussed, and this is the kind of a solution we came up with. So I would like to know your opinions, sir, about it.
Yeah, but I divided your part in three different. One is ecotourism, because that the elephant, what happened? The elephant having their strong memory and it has their own path. The elephant corridor. So any kind of disturbance comes, then the elephant used to come up, reaches to the human. We used to say that anthropology and animal and human conflict and all. There are too many things, ways or reasons are there, because that shortage of food in the territory, and the human making development in the elephant corridor route. These are the things where that elephant comes and approaches the human settlement region. So that one we should avoid, and we should identify the root cause. Okay. So then only we can able to come out. And the second thing about the already Kaziranga Park and other areas, the peoples are having the elephant safari and other thing. We should have identify the proper stakeholders, and you have to make a eco-friendly tourism development. I'm coming to the second point, where the community also engage, and community economic level also, their livelihood also increases, so that ecotourism will become the best one. Okay, for example, in some places they even many tourists, they like their native way of style, not their tourist native, their particular tourist spot native. So we have to come up with that eco-friendly and the native style of accommodation and food and all, so that we can attract more tourists in the tourist peak season. That is one. And we can keep it the indigenous method. Okay, they should not come out from the indigenous and Indian knowledge system. Again and again, I am approaching why, because many places that the indigenous system is vanished, and we are giving our new technology. Sometimes the new technology and things not suitable for the location, but since we are insisting, so we should avoid such kind of things. So you rightly pointed out. I am strongly recommend that single hand never makes a noise. So we should join together all kind of multi stakeholders. Then only we can overcome from the issue. Otherwise, everybody prepared our own, but there is no connection. Okay, there is no integration, so no use. So you prepared one, I prepared one, somebody else will prepare another one, third person prepared one. So we come together, one discuss it together, then we will overcome from the issue. Okay, then only it becomes the other issues are very difficult, especially in disaster management.
Right, sir. Thank you so much, sir. And another point I really appreciate that what you mentioned is about Indian knowledge system. That is very, very true, sir. Regardless of whatever fields we are, we have to go back to our roots, and it's high time that we should appreciate that and use it in our day-to-day lives in whatever we are doing. Because
Yes.
they had immense knowledge. It was again scientifically proven. It was not random or just part of the system. They had thought about it and then they were using it. So in today's times also it proves to be right. So it is high time we have to use it in a right amalgamation with modern technology and our traditional knowledge. Thank you so much, sir, for your
Okay.
insights, sir. Thank you.
Thank you.
Muthukumar, sir.
Hi, Gopi, how are you?
Yeah, I'm good, sir. Tell me, sir. Go on, sir.
No, I just want to thank you, sir. Thank you for the discussion. But just wanted to share some insights from my personal experience. I've been handling this DMP, and I've been personally involved hands-on in oil and gas drilling projects across everywhere in the world, not only in India, especially in Brahmaputra and Assam area, everywhere across the Godavari, Krishna, riverbeds in Nigeria, in Kenya, in Ghana, and everywhere across the world. One of the things I've seen, and India especially, one of the things I've seen in India especially is that, which is the actual truth, sir. I heard of what you're talking, Professor Moni and Madam talking about it, but the problem in India, which I have seen, is that we, especially when systems are involved, infrastructure is developed, roads are constructed, bridges are constructed, ecotourism developed. When anything modern developed, the biggest problem in India is that the traditional ancient knowledge is ignored completely. It's a truth, irrespective of that's a possibility. The engineers or even IAS officers, we have no knowledge about what is reality. But they have the power of authority, government power and money, and private institutions are given contract, but most of them are uncles and relatives of politicians. None of them have any knowledge about what is really happening. So when they do some infrastructure, what we identified is that the traditional ancient knowledge from the locals are ignored, actually. They're uneducated or unorganized, disciplined. The modern engineers, I'm not blaming anybody because they're working. They always believe that a quantifiable, calculated analytical methods are the only thing which will work. A software will work, an AI will work. But I have seen, sir, I have worked with a lot of surveyors, even ideology people and everybody. But beyond modern thing, when you want to construct a site or a bridge across a river to take your drilling rig to drill in everywhere, The local 70 to 80-year-old guy has got a much higher knowledge about the last storm came in, what is the height of the river went in, where was the flood happened, everything out much better than any of the engineers, any surveys we used to have. And those guys, we used to travel with them on boats and everywhere. The second issue which I see here is that we also do not focus on what is important. For example, we talked about earthquake and all. We all know that Tamil Nadu has got a very low risk in earthquake compared to North India, Himachal, or towards Uttaranchal or Northeast India. Compared to that, Tamil Nadu is a very, very low category. We get a lot of earthquakes about magnitude 3, 4, even up to 5. Even recently, in January 2026, there was a magnitude of 3 earthquake was happening in Tamil Nadu. Nobody will realize it, as you know. And so low. So what we do not, Tamil Nadu is more prone to floods and storms and issues like that. And thing is that what we also have as the problem with the education system is that it is not focused on what is the real problem. It's all theoretical. Somebody creates a, we talked about NEP, and I have gone through the NEP. Somebody sits there and creates something, and then ultimately it applies everywhere in India, whether it is applicable locally or not. Let's take an example of the Brahmaputra, right? So we talked about it. The locals know. The locals know exactly when the Brahmaputra is a flooding thing. They never thought that they have a permanent place in Brahmaputra. They live temporarily. They understood the nature far better. It is the modern people who went out. Nobody lived in Assam. Nobody even seen a Brahmaputra in their life. But they made a plan sitting in Delhi or Bombay. And then they took and constructed roads and bridges without bothering anything out, without knowing what is happening there. And that's what they do everywhere in India with respect to anything. Something happening in Kaveri Delta here, somebody sitting in Haryana, an IAS officer from Haryana will be planning for Kaveri Delta without knowing anything. And they will be implemented by government officials. See, irrespective of what we teach people, irrespective of what we want to do, it is not useful in India because we talked about, Professor Moni talked about Japan and everything. But Japan is highly disciplined. Children are disciplined. They understand what is the reality of the situation. They are taught like this, highly disciplined people. And here another problem in India is that irrespective you teach anybody, heroism highly developed here. In every movie, Indian movie, is that the worst guy is a hero here. And he does all the indisciplined things. And we celebrate it as a big thing. They even vote for them. The most indisciplined people will vote also. We make them. We treat them as the heroes of the world. Every movie in India is absolutely indisciplined people are the heroes, actually. They don't teach any discipline to the people. So everybody thinks like a hero all the time. So they do want to do things in disciplined way. And nobody if you are a disciplined person, you are criticized in India. If you are a proper person, you are criticized in India. It's true. Everybody knows about it. Let us not hide the facts. We're all qualified people. And unless you change the fundamentals, sir, that is, we have to face a situation. So most people in India, they face a situation as it comes. Nobody is ready, prepared for it. Nobody is, about 20-30% probably, yes. But 70 to 80% of the people are just want to live on day to day without managing it. So these are the major issues in India we are facing. And probably someone like you, instead of, I always say that in every meeting, we should not talk theoretical, we should do it, never works in India. What we can do is to understand the fundamental, the weakness in the system, that what is the practical application, and we have to apply that and do it what is important locally. If we are talking about, let's say, a problem in Tamil Nadu, in Kadalur or someplace, what is the major problems that can happen there? They have to talk me like that. There's no meaning to talk to some people in Kadalur about some very complex scenario which they never see in their life. So I just want to suggest that we have to create the localized problem-based teachings to the people, and and practically apply what is possible. And that's the only solution, sir. Thank you.
Yes, sir. For your comments, I just to add only one point, sir. If you are getting the chance, if you are traveling the Odisha state, all the houses in the coastal region, especially in the Barampur and the Gobalpur region, even the Puri region, if you are traveling 120 to 200 kilometers from this coastal area, the houses are very narrow, sir. Not even 6 feet width of the house. Length is 60-70 feet, but the width of the house hardly 4 to 5 feet only. But that is a traditional house in every village. No impact happened by the cyclone. cyclone enter the house, wind, and pass through the house, because the house structure does not allow the spiral movement inside the house. That is a traditional knowledge. The Indian knowledge system developed the house, they construct the house. But new house constructed, very big hall, structural building. Once the wind comes, that means it's flown up the houses. So I rightly pointed out, whenever we are going to implement any engineering technology or any kind of structure or any kind of development, we must, it's a mandatory, we must understand the local knowledge. Then after that only we have to implement. Without understanding the local knowledge, whatever the infrastructure you want to develop, no use, sir. It happened.
No, I agree, sir. Correct.
It happened in the recent Wayanad landslide. Construction site is washed away. Why? Because they didn't understand thoroughly about the structural measurement. I produced more than 3 PhD from the landslide. Very unfortunate. The landslide is not unique for every place. Place to place it changes. So every place is a unique. But unfortunate that the community engineering or whatever may be, even geologist, the entire landslide they are making as a unique. Not every landslide is a unique. Every place is a unique. Based on that, you have to make a uniqueness. But people's making the holistic one system to implement in many places doesn't work, sir. That's why we are having a lot of failure in the after the implementation or during the implementation process. We should have, you have to understand thoroughly, sir.
That's exactly the point, sir. I'll give an example.
I would like to give one example, sir. What kind of operation mechanism we are going for eye? I cannot do the same mechanism for my skin, sir. The people are taking the same knife to operate the eye, then the eye will become the blind only.
Yeah, true. No, sir, one thing I'll tell you, I've seen, see, we all laugh at people, Africans, right? And I have traveled extensively in Africa, Nigeria, in Kenya, in Ghana, in South Africa, everywhere. Very deep inside, not in cities or capital cities. But I've seen that they are primitive in their knowledge, right? They don't talk, they're not highly, but they know how to live, sir, beautifully across the flooding rivers. They know exactly how to live very comfortably, and they teach us all the modern people how to construct kind of a small jetty or whatever. They don't know exactly what to do. But you look at Chennai, for example, across the Kuvam River, everywhere, absolutely no knowledge about how to live in riverbed. They're all coming from some villages, or they just gone and given some houses there, huts, everything, with zero knowledge about it. They occupy the position near the seashore, near the things. And even, for example, I used to talk to the fishermen of India. Actually, they know exactly how to live near a coast. Now they all moved away from them because the modern buildings have come. People see that zone come 500 meters, all kind of things on paper. But people constructed huge houses, even 200 meters. Even our people are there. Very celebrities are constructed 200 meters from the shore. Against the sea is a zone of 500 meters, beautiful buildings, and they destroyed the entire. Yeah, so the question is, the local knowledge is important. As you mentioned, we have to teach people based on localized problems. We don't have to teach what will happen in Japan, in India, actually, or what will happen in some places in Himalaya. What happened in where I'm living now? Suppose I'm living in a place in Chennai or Tamil Nadu, what are the disasters can happen there, and I want to be ready for that. That's the teaching has to happen. India is a very big country. But our problem is our education system is so poorly managed that somebody sitting in Delhi and creates a curriculum that people sit and discuss about what will happen in Himalayan disaster in Tirunelveli. It's no meaning, sir. So people like you are already there. You have to ensure that those kind of idiotism has to be removed from our curriculum. We have to, disaster management should be based only on local problem that can occur. And people are taught that then they will be interested. People will show interest, and ultimately they will participate in that. You can't teach somebody what will happen in Himalayas or northeast of India, or that will happen in Tamil Nadu, and teach them in the curriculum. That's where we are losing, actually. And that's a part I think I want to implement, sir. Thank you.
Yes, sir.
Mr. President, Sanjay.
Yes, sir.
Sir, go on,
afternoon,
sir.
sir.
Custodian.
Sir, can I ask one question? Yeah,
Yeah.
sir, excellent presentation, sir. I have just, since you mentioned about the landslides. Now, landslides, we know that one is the earthquake, geological reason, or second is climate change, third, man-made causes. So if we keep the man-made causes out, the other two are basically earthquake, that is geological, and the climate change. So if in an area where there is there is a intermittent earthquake, but like let's say below the Richter scale of 3, so which is only the instruments can actually measure, and and climate change also is happening. So is there a way to know what is the contribution between the geological causes and change causes for the landslide to take place? Is there any method, sir?
Yes, sir. Yes, sir. See, for causes of landslide, if you are taking it totally away out of that human, you can say anthropogenic impact, natural parameter also is an influence that we can able to understand, because many landslide, see, except earthquake, because many landslide used to happen because of the heavy rainfall. Heavy rainfall occurred. That heavy rainfall, why I am mentioning the heavy rainfall, when you are talking about the rainfall, we must understand that distribution of the rainfall, whether the average rainfall of the particular place is 1000 millimeter per annum, whether the 1000 millimeter per annum is distributed across the monsoon period or only 2-3 days. If it comes to 2-3 days, it is giving that landslide impact, and it is not sustained in the groundwater resource there, sir. Why? Short time, the water doesn't have the time to recharge it and penetrate down. It's water away, everything it's will go away. So natural cause, there are so many parameters are there, more than 15 parameters: geology, geomorphology, soil, slope, drainage, lineament, lineament density, drainage density. So like that, natural parameter like rainfall intensity, rainfall frequency. This all we have to keep it. 10-15 parameters are there, if you are keeping out of the atmospheric effect. But if you include the land earthquake within it, then it's a multi-hazard. One is meteorological, another is geological hazard. Then we should go with that different kind of mechanism. Why? If the earthquake, there is no earthquake, only landslide is there. The construction mechanism different when there is a earthquake also within it, because the structure, whatever the structure you are going to implement, the structure must withstand against the earthquake. If the structure is not capable to withstand, then no use of making that one. So we should understand the multi-hazard is different one. Okay. For example, you are going by riding the bicycle or bike. One person coming from one side, okay, you will manage it adjacent. The left hand side also one person comes, front also, back also. So we trapped. So we have to ride the bike based on that only. Similarly, the one side is meteorological impact comes induce the landslide. Another is the earthquake also there. And then accordingly we have to make a strategy to reduce the landslide impact in that area. Most importantly, we have to understand thoroughly about the geology, slope, and soil characteristics in the area, because many places that landslide happened due to the slope failure. So which factor majorly the slope failure occurred? If you find out the main root cause, we can resolve the matter, sir. That is very, very important.
Okay, sir. Thank you, sir.
One last question you can take, Mr. Kasturiran, sir.
Yeah, thank you for giving me this opportunity, Mr. Gopi. And it was a wonderful program by Professor Guru Balamurugan. It was it was an important topic as of today. He mentioned many things about he gave a lot of insights about the seismic hazards and impacts. And we all got really enlightened with a lot of information. One important question I have is that when Dr. Balamurugan said there are no advanced early warning systems like tsunami, it's all captured through satellites, and then the no early warning system to predict the timing or the place, the location of the earthquakes that are going to occur. So it's after many decades of our research and the worldwide, we have been facing earthquakes in most of the countries like Afghanistan, Indonesia, this side, Japan, uh, Taiwan, and north part of India like Uttarakhand, Himachal, many places. So we are still not having an early warning system. And why can't your university, in tandem with the Ministry of Earth Sciences and the other organizations like IIT or institutions like IIT, to do some sort of research, even in close coordination with other developed countries, to find out, like tsunami, how we can use some sensors, mainly in the earthquake-prone areas, the countries, the geographical locations. Especially Afghanistan is another epicenter. Even recently, about 6 months back, we got even Delhi was having up to 5.6 Richter scale. So why can't we have some early warning systems, and what sort of precautions the citizens, the ordinary citizens should take? See, professor said there is a 10-minute video. So what I am saying, if and professor also said in Mumbai, people even after getting the warning from the police department, they don't bother. So you said it's an ignorance. I will say it's lack of awareness about the seriousness and the impact on these earthquakes or the tsunami. So if all the concerned departments, the ministry, your central university, all put together, form some sort of a technical group, a think tank, and analyze, do some research, put something, the sensors like tsunami, we have sensors in the deep sea, they put the sensors and then they get the data, collect the data, and then study the movement of the seabed, and then they give the early warning system. The same way, like, why can't we do it for earthquakes also? Number one. Number two, the awareness videos should be put officially by the Ministry of Earth Sciences, state government, even your university. They should join together and publicize widely. Like Professor Moni said, even social media can be used as platforms for creating awareness. But social media, most of the people who are all or either the youth or the Gen Z and the middle-aged people. But I'm talking about the people who are in the rural areas, the villages, the elderly citizens. They also should know. So create some awareness, use the TV media channels instead of watching the TV serials. If this can be put as a documentary, create awareness, keep on advertising, even these, so yeah, these things have to be brought in. Otherwise, one is lack of awareness. Only these people are responsible, and they can only do such things to create awareness and alert the people. If something is alerted, like early warning system of tsunami, the people are asked to move inside from the coastal areas, at least a few kilometers inside. So that sort of warning system, the building, they should evacuate the building, come out. The same way, some mock drills have to take place. There is no mock drill. So I don't think so. These are taken care by the respective departments, government, and the NGOs or the universities, the institutions. So what are the steps you are taking from your side, from the Central University?
Okay, sir, first I give the response to the earthquake related. Sir,
Yes.
in the measurement of the earthquake, we have done some couple of studies in this regard in Gujarat also. We published the things, and
Right.
Assam also. Till
Right.
today, sir, there is no mechanism to measure the pressure, how much pressure the particular region is accumulate due to the plate movement. We don't have that mechanism to measure the pressure. Because if once that technology develops, then we don't have problem to give the early warning system, especially the earthquake. Because, for example, if it is I given the example. If you are keeping the solid rock, you give the pressure.
Right.
We have to measure the pressure, how much is that rock is experience that pressure. If you accumulate and make it, we can develop.
Right.
But from where to where, how to, these are the still it is many researchers are doing. As a geoscientist, what we are doing, this pressure accumulate is giving some kind of signature in the surface of the earth. Suppose if we used to call it a neotectonic. If this kind of pressure is existing in the particular region, the morphological, that means the surface of the earth is giving some kind of symptoms. We have to identify such kind of signatures, and we come to know that, see, this area may going to have the more chances of earthquake. But even Ministry of Public Information Bureau also give, we cannot very precisely give that exact time and date, this time, this date is going to happen the earthquake. But we have to identify the signature, and we have to identify this area is prone to the earthquake. We used to call it a technically neotectonic region. Based on that, what kind of building codes, what kind of mechanism one should do, these all we have to implement, sir. Now Delhi and some other state only they implement the building codes. If any new building you are going to construct, you have to follow the building codes. Yet to come, sir. Of course, you rightly pointed out awareness and other things also play a major role. Because at the end, people are compromising their cost, sir. For example,
I agree, sir. Cost is immaterial when it comes to human lives. The damages that it is going to cost to the human lives, normally we, with the past data, what we have, like the epic centers we know, like Afghanistan, Uttaranchal, Himachal, Jammu Kashmir, or Bhuj in Gujarat, those areas are normally prone to earthquakes, and we know up to what Richter scale it comes to. And I don't want the specific dates, but at least a tentative period, like from this date to this date, this can occur. And we don't want any specific Richter scale. Some approximation and say that, around this Richter scale, the earthquake can occur. So people they have to be alerted, like some alarm system, early warning system, people, some sort of indication so that they are alert. And immediately if something happens, immediately they should move out of the buildings. No, that's alertness, and that sort of thing should be undertaken by the government, the state government and the central government. They are both responsible. And I would say that the university like yours, you have done a lot of research, you have traveled extensively throughout Northeast and East and other part of India. So you know extremely well about the geological studies you have done, and you know pretty well how like rocks, the areas where they have rocks or mountains, where how it should be done, and how it should be done in a normal plain area. Those things. Accordingly, the census can be devised. At least some information data can be taken even from the past data. The analysis can be done, and some sort of equipment and early warning system and things can work out. I don't think so. Like
yes,
the way
sir,
they have done
it will
for
take some
tsunami.
time, because I cannot say that there are some challenges are there, sir. For example, when you are going to the thermal gradient, the depth increases, temperature also increases. Some of the devices we cannot be able to operate in the particular temperature. One thing. Second thing, when the temperature depth is increases, the scale of accuracy what we want we are unable to detect, because heat pressure is also disturb the information. So maybe after a certain period, the people will make such kind of device where we can able to get more accuracy and other thing. For example, sir, the last 15 years, you know that mobile phone camera, how it was 15 years, how it is now. So similar way, the technology also is drastically developing, and it's going up. So after a few years, we can get such kind of sensor based or some kind of algorithm based on the past history. We can get this one. For example, sir, if for earthquake last time happened, 57 kilometer and its earthquake magnitude is 5.7, but it's giving the huge impact. Normally, people believe that shallow level earthquake only giving major impact, but the 57 kilometer it's giving because it's a rock decided what kind of lithology in that area. The soft rock is giving a major impact. So these are the very naturally it doesn't have any boundary, sir. But when you want to do some kind of modeling and other thing, we should have the lot of conditions and the restriction. So sometimes it's very difficult to overcome from those conditions also. If we believe that in future, once we resolve, we can able to do that part. Sir, anything?
Thank you. Thank you very much, sir. Thank you very much for taking your time out on Sunday morning to be
Thank
with
you,
us,
sir.
sir. It was an excellent session. We all had a lot of
Thank you,
takeaways
sir.
from it. We stay connected, sir. Thank you very much, sir.
Thank you, sir. Thank you.